Yeah. Hi everyone. Hope I'm audible.
Yeah.
Yeah. Okay. This is Group 5. We, as part of Probability and Statistics module, we present the following project from our team. So this is prediction of probability of default based on a dataset from Taiwan. Our team members are Shreyas, Shashidhar, and Ramabhadran. So in this connect, let's discuss on the introduction to the topic, like the one that we are going to present. So this is based on the probability of default. We shall see what is the data set and overview of the data set, what it includes and what are its key features. We shall analyze different models and methods which are available and try to apply them on the given data set, and we can list our conclusions. So we shall see these topics in the upcoming slides. Talking about the probability of default, this is a metric actually that estimates the likelihood of a borrower uh, failing to make a payment. That means let's say we have credit taken from a bank, or a loan, and we are paying EMIs, and how likelihood is that, like, we actually uh, default for the upcoming cycle or upcoming month. Okay. And how this probability of default is useful is like, let's say the bank wants to know what is the risk of a default. Okay, this parameter can help them. And let's say they find out, like, there is a high probability of default for a specific person or specific borrower, so then they can limit their credit for that borrower. Okay. And they can also go ahead and adjust their interest rates so that they can be profitable in the market and go forward. So these are different uh, useful items, and that is defined by the probability of default. So this is a useful method. So let's see what does the data set contain. So this is a data set that we chose for our analysis. It includes 30,000 clients over recorded from April to September 2005 in Taiwan. It includes features like age, gender, marital status, and much more relevant features which are quite useful for our analysis. So it also includes repayment history and billing amount, which will also help us to correlate our prediction. And lastly, it includes the default and non-default items as 0 and 1. So this is a final output that is being available in the data set for the given items in the data set. Let's go ahead and see what we have done next. And this is the steps that we have performed in data processing. So firstly, we took the data set and we checked whether does it have any items missing, or whether it is corrupted, or whether all the relevant items are present. So this was done using Python pandas, and we found that data is very clean and useful for our further analysis. Next part is, while we performed the analysis, we found out there is a class imbalance between the data set, something like between the defaulters and the non-defaulters. Okay, so usually this kind of imbalance, it affects the model output that we have, but that we usually consider for training. And so to avoid this, we actually started resampling the data. So while we resample and apply these for our model, so we found, like, okay, this is actually worsening our output. Okay, and then we actually dropped the resampling part and we continued over using the data set as is. Going forward, So as per our analysis, we found the key insights presented over here. So the further slides are being explained by Shreyas. Shreyas, can you take it forward?
Yeah, thank you, Shashidhar. So talking about the exploratory data analysis we found on the data, there were a couple of key insights that we found to note. First of all, the average client age being around 35 years, the mean credit limit being around $167,000, the repayment status, as noted in the class imbalance, being more towards non-defaulting than defaulting clients. So, and we then again we measured the correlation between the variables. So correlation is just a measure of how one variable moves with respect to the other variable's movement on a, let's say, graph. So the correlation, an interesting thing we noticed is that the demographic information, that is the sex, the gender, the marital status, and the education, these had little to negligible correlation with a client defaulting or not defaulting. And as a consequence of which, we decided to drop most of the demographic information from our data when we outputted the final X for our training. So can we move to the next slide?
Okay.
Talking about the models, so there were 4 models that we chose to incorporate in our modeling. The first, let's move to the next slide. I'll talk about it then. Yeah, so the first model we went with was a pretty obvious choice, being the logistic regression model. Since it's a smooth curve model with a output restricted between 0 and 1, it's an ideal choice for modeling probabilities, such as the probability of default in this case. And as expected, the logistic regression model performed pretty well on our testing data, our testing data being an 80-20 split from training to test. So the test accuracy was around 82% for the non-defaulted clients and 72% for the defaulted clients. I should mention like Shashidhar mentioned that since we decided to go with the data as is without any resampling, we chose to measure the model performance for both classes independently and for checking if any model was performing especially bad on the minority class. Moving to the next model, we decided to go with a decision tree classifier since it's a good model for modeling complex relationships, and it's a good model for basically any classification task which this can be considered as. The decision tree model saw a slightly better performance than logistic on the majority class, but saw a much worse performance on the minority class, being at 69% for defaulted clients. Next, we went with a few more complex versions of the decision tree, being random forest and XG boosting. Random forest being a cluster of decision trees where each tree is trained on a subset of the data. So this model is typically very good for handling class imbalance. And for random forest, we noted that the model performance were actually pretty similar to the decision tree classifier. Finally, we went with an XGBoost classifier, which is basically a sequence of models where the first model, being a weak model, is trained on the entire data set, and subsequent models are trained on the mistakes of the previous model. So, but XGBoosting saw the worst performance out of all 4 of them. And then finally, we decided to implement a voting model, which was basically a combination of all these 4, where the final data point being defaulted or non-defaulting would be decided based on a majority voting. Can we move to the next slide?
Okay.
So the conclusions from our statistics. So the first thing we noticed, as expected, the logistic regression and the final voting model performed the best out of all the 4 across for the both classes. And XGBoost surprisingly saw the worst performance out of all of them. Can we move to the final slide? Penultimate slide. Yeah. So talking about the team contributions, you can see them on your screen here. Ramabhadran was responsible for checking off class imbalance and helping me with training the models with resampling techniques, where we concluded that model resampling was worsening the information for worsening the performance. Sorry. I was responsible for the modeling on the data, and Shashidhar was responsible for the EDA analysis, the pre-processing of data, and for all the documenting work. Can we move to the final slide? Yeah, thank you for listening to our presentation.
Thank you.